Chapter 3H looks at correlation and causality. If we look at the graph here, our explanatory variable on the x-axis is the amount of IKEA stores per 10 million population for several different countries. Our response variable on the y-axis are the amount of Nobel Prize winners per million population for that country. Looking at this positive, fairly strong correlation between these two variables with a correlation coefficient of 0.82, we can say that these variables are associated. But does that mean that one way that we can increase the number of Nobel Prize winners in your given country is to build more IKEA stores? Probably not. Just because they are associated does not necessarily mean there is a causal link between these two variables. Correlation does not imply causality. A correlation tells you about the strength of the association between the variables, but it doesn't tell you anything else. It does not tell you about the source or the cause of the association. Let's look at a real life example of this to clear it up a little bit. There is a strong correlation between people who faint and people who use sunscreen. Does this mean that wearing sunscreen will cause you to faint? Often there is an underlying third, or in more complex cases, more than one other hidden variable, which are causing both of the other variables to have an observed association. In this example, the third underlying variable is temperature. When the temperature is very high, it is causing people to use sunscreen. Although when the temperature is very high, it is also causing people to faint due to heat stroke. So when the temperature is high, we are observing an association between people wearing sunscreen and people fainting. There is no causal link between sunscreen and fainting. By itself, an observed association between two variables is never enough to justify the conclusion that the two variables are causally related, no matter how obvious the causal explanation may appear to be. Chapter 3I looks at which graph you may want to choose to explain or display the data between certain types of response and explanatory variables. This table can be used as a very useful guideline for deciding which graph can be used for these different types of response and explanatory variables. For example, if you have your response variable as a numerical data set and your explanatory variable as a categorical data set, the best way to display this data is in parallel box plots, or you could choose parallel dot plots.